So this lecture is starting your first, second, third, and nth game engines. All right. Those of you who don't know who I am already, my name is Sean Middleditch. I'm a senior here at DigiPen. Some of the games I've worked on are Subsonic, Sonar, and Core. I've been programming for quite a few years. I think I'm coming up on 19 years in C++ here. And I am a total architecture nerd. I just love thinking about fun ways to overcomplicate everything I possibly can. So this lecture is about a couple different things. Primarily it's about starting from scratch. I know there's a lot of people who have problems starting a new project. They sit down and they think, I want to make a game, but I don't know where to start. And they can never figure out exactly the best way to just get going really is. This also will help you on the other end of that spectrum, is getting a game actually done. Plenty of people have this tendency to start a project and never really finish it because there's all these little details that they worry about instead of just making a game. And then that's also going to go over a consistent way to help make sure that your games will continue being good, which is why this isn't just about doing your first engine, but your second, third, so on and so forth. So one of the most important things we got to really think about first here is what exactly a game engine is. I went on Wikipedia, which everyone knows is the sterling source of information on the internet, and I found this definition that I really don't like. It says a game engine is a software system designed for the creation and development of video games. The reason I don't really like this is this leads people astray in thinking, I think. So a game engine is nothing that you have that's just sitting there that helps you make a game. Right? A game engine is whatever is sitting underneath the game you happen to be working on. In most cases, a game engine isn't first designed and then a game built on top of it. A game is built and an engine just happens to exist as a consequence of making a game. Right. Then also, because this is the Engine Architecture Club, I thought I'd bring up a little something about architecture. This is Wikipedia's definition here. Software architecture discipline is centered on the idea of reducing complexity through abstraction and separation of concerns. It's just a really fancy way of saying that software architect's job is to simplify things as much as they possibly can without making it simple to the point of not being usable. What it's absolutely not about, what being a good architect is not about, is adding tons of cool features and all kinds of complex algorithms and other things that you don't actually need. That's not part of being a good architect at all. There's actually a term, I forget to put a slide in here about it. Joel on Software has this great article about Architecture Astronaut. What this is a person who likes building all these cool features and foundations, and they keep building all this technology and piling it onto their software until they're up to the moon with all this stuff that they don't need. And it overcomplicates the project, it slows everybody else down. In quite a few cases, it'll completely kill the project, that kind of thinking. So this lecture was inspired by an article called Write Games, Not Engines. A little excerpt of it here is that you can sit down and write a game without writing a pre-written engine. And in fact, this is very often the better approach, regardless of why you want to write an engine. Everyone should definitely check out this article, read through it. It's not particularly long. It really just kind of goes over the reasons why thinking about engines instead of thinking about games can lead you astray very easily. So one of the other reasons I really want to do this lecture is I know that we're going to be talking about a lot of really cool techniques over the summer here. We're going to go over possibly threading, metadata. A lot of people have been asking me about. There's all different kinds of things. Really cool, complicated features. But you don't actually need any of them to make a game. Right? So our first lecture here was about component-based design. You don't need components to make a game. Games have been written for 30 years now without components being anywhere even close to being in the picture. Right? If you're making a simple enough game, components aren't actually going to buy you anything. It's just extra complexity and the added benefits don't outweigh the implementation cost. So you have to be aware when you're designing your game, do you actually need any of these features? Even the ones that we'll sit here and say are the best things ever, they're not always the right tool for the job. Same thing goes for metadata and scripting. You almost probably don't need those in any game you're going to write in DigiPen. They're cool features. You probably really don't need them. Editors. I've said quite a few times that every game should have an editor because it helps with your iteration time. But if your game is simple enough, the editor is actually just going to take up a lot of time, and you might not build as good of a tool as possibly Notepad would be for, say, a tile-based game. If you're going to build an editor, you've got to sink in a lot of time to make it really nice and really usable. And you possibly just don't need to spend that time, and it might actually just slow you down. Same thing for, say, art pipelines. Right? If you don't need art, you don't need to worry about an art pipeline. And a lot of games don't need art. Subsonic was one of the games I worked on. It went to IGC, finalist. it didn't really have art. It was circles, it was triangles, lines. It was all completely abstract, very much like Geometry Wars. You don't need to worry about art depending on the kind of game you're making, and especially here in DigiPen where you possibly don't have a huge art team. Just even trying to think about how you're going to get art in the game is just a complexity you don't need to deal with. What you do need to think about running your game is just actually the bare necessities to get up and running. What is the absolute minimum a game needs? Right? You're going to need to open a window that you can draw some graphics in. You're going to be able to get input from the player so you can control something moving around the screen, run whatever your game logic is, and then especially for TCR purposes, you're going to need menus and intros, help screens, stuff like that. It's pretty much all you need. At that point, you have a game. Right? So you want to keep things simple. If you've got an idea for a game, sit down and just write that idea. Implement it, prototype it, get it up and running. Write the absolute least amount of stuff you can get away with. And if you're going to spend any time writing code, spend it writing the code you actually really need right then. Right? If you don't need, if you're thinking you're going to need maybe scripting a few months from now, don't waste weeks when you're trying to get the project up and running implementing a scripting engine. Right? You might not even ever use it, and you've just wasted a ton of time implementing a useless feature. All right, so like I said, you're going to need to start with getting a window with graphics. This is really easy, but I've talked to a few people who said that they've been working in their game for a while and they actually haven't gotten this far yet. This is probably the first thing you should do. All right, this is something you get on MSDN. You cut and paste some code about how to open a window with the 132 API, and you're done. All right, I used Glut in a game I'm going to go over here in a few minutes. Glut is like maybe 10 lines of code, and you've got a window open, you've got inputs, graphics, all that stuff. Didn't take any time, right? A lot smarter. Same thing for drawing something on screen. You get on MSDN, you can cut and paste a little bit of DirectX code. You can cut and paste a little bit of OpenGL code if you're using Glut. Just get something drawing on the screen, as quickly as possible. Right. So then, once you got something on your screen, you got a window open, you've got little triangles sitting there. Hook up input. Again, MSDN, cut and paste a little bit of code. Just get it so you can actually move your little triangle around on the screen. All right. This isn't a game at this point at all. Obviously, you're just moving something around the screen, but you've actually got something you can play around with, right? And something that other people now can sit down and start adding stuff to. For example, once you have a window up and running with a little guy moving around, another member of your team could start implementing game logic. They could start implementing a really simple little collision library that can detect when two squares are on top of each other and maybe make one of them turn a different color. Or you can start implementing having another little square that actually chases the player around. So you've got technically your first enemy up and running. And you can have all this done within 40 minutes. Easy. And then you're going to definitely want to spend a little bit of time getting menus, intros, help screen. That's again mostly for DigiPen purposes. If you don't have those, you fail the class. So at least make sure that you are set up for that kind of stuff. But there's really nothing to that. You don't need to worry about fancy GUI libraries. And a lot of people have talked about embedding Chromium or using all these really fancy widget and designer tools. You don't need it. If you can draw a box and you can draw text in it, you can detect if the mouse is within the bounds of the box and the mouse button is down, you have a button and you can implement UIs. And you can start with that and not worry about anything more complex. So here we go. These few little steps, which is mostly, again, just cutting and pasting stuff off MSDN or Stack Overflow, wherever you get sample code, you've got something that kind of looks like a game. You've got a little guy on the screen you can move around as your player. You've possibly got that other little guy that chases you around as an enemy. You've got another square that you can run into, collide, you make a win condition. You have a game. It's a really boring game. It's ugly. But it's something that is playable. It's a foundation upon which now the rest of your team can start building, and you're not all bottlenecked waiting for this engine guy to build this perfect engine that you can't even open a window on yet. Everyone can start iterating a lot more quickly at that point. And then once you get to that point, now you start worrying about all the complexity and all the features, things like that. Sure, you've got all this cut and pasted code. It's not good. You can worry about refactoring. If you've got some code you copy and paste in a few different places, now is the time. Now that you have something working, something on the screen, something you can see, something you can move, something you can play with, now is the time you go back and think, okay, what's the proper way to abstract this? What are the APIs I'm going to need? What features does my team say that I need or that they need right now that I need to go and implement? All right, so what I did for this lecture is I decided to try to build a game in 8 hours to show that it could be done. All right, so this is just me by myself, 8 hours, no more. I wasn't really strict in the measurement. It was kind of eyeballed, but about 8 hours. The source is available online. I'm going to link later on in the lecture so you guys can check it out. You can see how absolutely bad the code is despite the fact the game's up and running and works. All right. So this game I call the Badass Bubble Battle Boyd Bots Bonanza. I'm kind of corny like that, so I'm sorry. The game has up to 4 players with Xbox controllers, which you guys might notice I have 4 Xbox controllers here. So after the lecture, you guys can come play this game and see how badass it really is. It's got both PvP and PvE elements. It's got this mechanic where you have the shield, which is both your way of defending yourself and your way of attacking the other players or the enemies in the environment. The enemies have a flocking AI, so they fly around, look kind of cool, look kind of intelligent. There's walls, there's some pits, there's survival mode. I didn't get sound in. 8 hours wasn't quite enough time for me to do that. And this also, I'll just bring up, the lecture is first, second, third, nth game engine. And again, this is absolutely my nth. All right, this is way past the 3rd game I've built. And there was no reason for me to sit here and worry about super complexity. I could just sit down and make a game in 8 hours. All right, so 1 hour in. This is all I had. This doesn't look very impressive at all, does it? No. It's a screen. I had it filled with a solid color. Drew in a white box. There's a little bit of a black object on the bottom there. And that was pretty much all I had. So what did I do in this first hour? And I opened Visual Studio. It's kind of the first step a lot of people actually seem to have trouble with. They, you know, a little momentum to get started in a project. Open it up, sit down, start coding. You'll get a lot further. I got OpenGL and Glut. The hard part there was basically getting online, downloading the Glut DLL, putting it in the folder, and then remembering what the 4 functions are to start Glut. That was a few minutes, not much to it. I created a game object class. And then I derived several classes from it. Inheritance, no components, right? All that evil inheritance stuff we talk about. For this kind of game, I think I ended up with 4 different types of objects. This entire code base has all of 5 classes in it, I think. So components would have just been, probably would have taken up more code than half the engine did. It would not have been worth it. And I can also do a little bit of input. At this point, the game, I could hit escape, close the window. All right, 2 hours in, we now have these yellow dots, all right? That's kind of weird, what are those? All right, so I added the Boyd object. Boyd is the term they use for flocking AI patterns. So this is just a simple little object that implemented the flocking AI algorithm. This algorithm is like maybe this long. I still managed to screw it up, so there were some bugs. But yeah, this much code. And again, most of hour 2 for me was actually just looking up the algorithm because I don't have it memorized. I've actually never implemented flocking before this. So it's mostly just research. And I implemented a math library, right? A lot of people like to think about, the ultimate math library they're going to build for their engines. For this 2D game, I have a single Vec2 class. That was all I needed. It has an X and a Y component, and I can add them, multiply them, do a dot product, do length, and normalize them, and that's it. That's all you need for a lot of this stuff. So I got that up and running. All right, so 3 hours in. At this point, all the dots got really small, and there's now this big blue dot. The big blue dot is the player. I got him up and running. 3 hours in, I had X input working. I could move a guy around on the screen. The enemies would kind of sit there and ignore you because I accidentally broke flocking entirely during this hour. But here I was with something that I could actually sit down and play with the controller, which is actually really satisfying. Your motivation just goes so much higher. You can actually play something that starts looking like a game. Hour 4 actually starts looking kind of cool now, I think. So now I've got all these enemies here, little yellow dots, and they're clustering together. They're doing the flocking. The flocking is working perfectly. You can see the little blue thing around the other darker blue thing. That's supposed to be the shield mechanic I was mentioning. So I had that working where I could hit the button on the controller and the shield would pop out and move around. Yeah, so I fixed the flocking, made the algorithm really nice, got the shield mechanic in, and even started implementing the basics of physics. The idea being that that white circle now I was not able to move through usually, unless I came from it from the bottom right. That was a little bit of a bug there, but 4 hours in. So hour 5, the enemies start looking a little bit more interesting now. They've got color and they're actually coming in and flying in at the player, right? So I got the anger mechanic, which is the PvE element. This is where the enemies would basically try to attack you after a amount of time. So they'd be flying around in little groups and they start getting angry, turning red. And when they got red enough, finally they just start doing a beeline at you. And suddenly there's actually danger in the game. There's something to avoid. I also note that hour 5 hours in, all right? That's less than game class, I think, the entire sit-down session, at least it was last semester. 5 hours in, I was done with graphics. I did not write a single line of graphics code for the next 3 hours, which was the whole 8-hour project. And had a complete playable game with what you saw graphics-wise there. Hour 6, start getting a little bit more in there. You can start seeing, actually you don't really see a whole lot different. I believe hour 6 was, yeah, mostly physics work. There are a lot of bugs, a lot of little things that I had to work on there. I'm not really much of a math head personally, so this was actually probably the hardest hour for me, just because a lot of trying to remember the kinetic energy algorithms and stuff from Physics 200, which I completely forgot and was basically just getting online looking up these algorithms and then implementing them slightly incorrectly. Anyone who is even moderately decent at math will probably breeze through that kind of stuff in ways that I could not. I also got the shield bouncing working, which is part of the physics work. Hour 7, I started making the pits a little bit more obvious what they were. It was actually pretty cool at this point. I changed it so that the enemies would respawn after you killed them. Not that you actually could kill them at this point, they had a key for that. But the enemies would spawn out of the pit, so they kind of look like they're rising out of the ground. Although I didn't have animations, it still seemed to look pretty much okay. So the bigger pits, still didn't have this stuff, I didn't have it implemented for you to fall into them yet, but the voids were a lot more intelligent, a lot cooler looking, seemed a bit more intelligent. And I got the multiplayer part working. So I made it, instead of just having a single hard-coded player, you now had 4 players that could join the game. And then the final hour, I updated the map, added a couple different types of walls, got some more intricate level stuff in there. So I got scaled boxes for walls. I actually didn't use a tile map for that. I know it looks like it should have been a tile map, and that's because it should have been a tile map. I tried to oversimplify, did everything in game objects. Probably not the best idea, but again, it got things up and running very quickly. Kind of hurt me towards the last couple hours. I actually got menus in there. The menus are bad. They would totally fail a DigiPen TCR. But again, menus are something you can spend another hour on, and I could have gotten up and running. And just lots of tweaks, fixes, making the game actually interesting. So the game is done. It is fully playable. It's got bugs. It's got some obvious bugs, and it certainly needs some tweaks to make it like a really great game by any stretch of the imagination. But it is, I think, fun. All right? It's pretty good shape for 8 hours, one person. All right? It's tiny. It's simple. I've actually been working on it a little bit here and there since I finished the lecture, just for fun, because it's so easy to just sit down and write. There's like no code there, right? It was almost all in one CPP file. The only reason I split it into multiple CPP files is towards about hour 6. There was enough code that Visual Studio's code completion would start going too slow. So I split it up into multiple files just to make Visual Studio stop being annoying. That's how small this game is, though. So it's not very big. It's not complicated. If I want to make a little tweak or a change, add a new feature, it takes no time. So we can sit here and talk about iteration of features like components. And it turns out that complexity is also a hindrance to iteration. There's a balance between features that help you do complex things quickly and just needless complexity that makes even simple things too hard to do. So if I could do this in 8 hours by myself, imagine what any 4 of you could do if you took a whole weekend. Right? You can not only make this game easily, you can make it way, way better than I did. And in terms of game class, this game would probably get, if you fix the menus for TCR reasons, get full screen support, which I think is required, you'd probably get at least a B. I mean, I don't grade the games, I can't promise that, but I'm willing to bet that if I turn this in, I could get at least a B. So a lot of people I know spend like all this time working on their games, like 40 hours a week sometimes. You see these teams upstairs just working all the time on their games, and you don't really have to. All right? If your goal is to like free up time for your other classes, to go out social life, something like that, one weekend, you can write a game that will pass game class. It's really not that difficult. And the other great thing is that if you decide you want to do all this cool architecture stuff and cool features and learn and explore, you've now got the rest of the semester to do that worry-free. So the code for this game is online. It's totally free for you guys to do whatever you want with, except use for game class, because that would be cheating. But if you guys want to check out what I did, go ahead. There's not anything technological that you should look at for inspiration, but more just kind of, you can look at it and say, oh, hey, look at all the stuff I didn't care about. Look at how I just half-assed everything and got up and running as quickly as possible. I'm going to go ahead and play the game here so you guys can actually see it. All right. So again, the game, you sit here and play around. You got the enemies that spawn. You've got the shield mechanic you can use. So you can open, knock guys around. Eventually they're going to get mad and attack me. You can also do this thing where you use the shield against the walls. When it expands, when it expands, it's got a little bit of force to it, and it'll actually send you flying. And you can send them flying. Hey, I got a screen right here I can look at. What am I doing? You trying to join?
Nope, it didn't work.
Yeah, let me. Oh. All right, hit A. There we go. Crap, there's too many of these little guys. Oh no, he beat me. All right, yeah, so the death in the pits is actually really unsatisfying. The more I played it, I realized that, the more I played it, I realized that it was hard to tell when you were going to die, especially because, you might not notice this, but you can actually fly over the pits if you're going fast enough. There we go. But it's not obvious when that happens. So this is the kind of thing where, again, some time spent just tweaking it and just kind of like maybe adding some really basic animations could take this. Oh, that was lame. All right. But yeah, just a little bit of time. Now that I've got a game up and running, I could spend a few hours doing some really simple animations, just tweaking the gameplay, making things feel a bit smoother, and take this up to an A game for game 200 easily. All right. Oh, yeah, see the guys are getting mad there at Sean. They don't. Oh, and now me. Oh no. Get away, get away, get away. They also, as you notice, you get redder. They will eventually kill you if you don't get rid of them. But, let's do one more round here. Whoa, okay, that was one of those fabled physics bugs right there, I think. That didn't look. That was dumb. Why'd I go down here? Why'd I go down here? All right. All right, so 8 hours, we had that. Not too bad for one evening of sitting down and doing a little bit of coding. All right, so just some of my thoughts I had doing this. This is the first time I ever wrote a game this quickly, because again, usually I'm the architecture guy, and all I think about are like the really cool advanced C++ stuff. So sitting down, just writing a game as quickly as I could. It actually took less time to write this game than the game object and component library for my last game in game 350. And that's included like the serialization. You got to be able to read the stuff from the files, like I was talking about in the component lecture. You got to get all the management, all this kind of stuff. It's just a lot of time getting that up and running and getting it tested and getting it optimized. This whole game took less time than that. And it was more fun too, honestly. As much as I like doing that cool C++ stuff, I just think I could play with. Right? That was so much cooler than just sitting there just doing with compiler errors for 8 hours. Most of the bugs I ran into were actually just me failing at math. Again, I'm not a math head. There was just, even right now, the current version I have, there's this bug where you gain kinetic energy sometimes when you collide with things. I haven't quite figured that one out yet, but it's a simple little thing to fix once I figure out what the math is. Probably when I sit back down again after I've had my head clear out for a while, I'll probably figure it out, no problem. Yeah, still having fun working on it. There's bugs, there's some tweaks, but it's up and running. And if nothing else, right, I've got a prototype now. So even if I decide that I'm going to go and spend 3 months building this amazing version of this game, I've proven the concept works. We just sat down, me and Sean just played and had fun playing it. Now we know that sitting down and worrying about the technology for how to build this game is a worthwhile endeavor, rather than spending months building an engine for a game that might eventually we won't find out isn't fun until 3 months too late. So this is really valuable, even if you are going to do something more complicated. So as far as the next step goes, I want to point out that you can't have a next step until you have a first step, which means you can't start worrying about where you're going to go if you haven't gone anywhere at all yet. If you have nothing, worrying about how you're going to design stuff it's just a huge waste of time. So some of the stuff I could add to this, power up, so that might be cool. Sound would be really nice. That's actually kind of a big one. The one level I have was kind of poorly done. I could either make some more, randomly generate them, do something like that. But I'm not going to sit here and worry about cool features to add to the engine. The only code I'm going to add to the engine is the stuff that I actually think I need. All right. So I might add components if I decide to start adding, like, say, 3 or 4 more game objects. At that point now, maybe I've got enough repeated code that'll be worthwhile to have a component. But if I'm going to keep the same number of objects I have now, even if I just add power-ups, again, that would be so much complexity that it wouldn't help me out at all. I wouldn't even worry about it. I might think about doing physics. The physics code is kind of bad. If this wasn't for a DigiPen class, I'd use a physics engine because this isn't for a class actually. But if this wasn't for you guys, for DigiPen, I would just use a physics engine because writing your own from scratch is just a horrible waste of time if you don't need to do it. But for you guys, and for like a project like this, I get to sit down and probably write this a nice collision library instead of the cut and paste math I have all over the place. So a lot of you might be wondering what this little sample game, has to do with people who are, seniors, juniors, the upcoming sophomores. So again, this lecture is first, second, third, multiple game engines, right? The approach I use for designing this and just sitting down and getting things done is going to work for any level of class, and it's going to work out in the industry as well. So for game 200, I said I'm fairly certain that this game for 8 hours could get at least a B. After I fix the TCR issues like the menus and all that. For game 300, the requirements actually aren't that much higher. If you look at the syllabus for game 300 and game 200, they're pretty similar. They probably expect the graphics to be a bit nicer. They might maybe like light or something, and some textures. Sound would be a requirement for both classes. But there's actually really just not that much complexity. The physics requirements for game 300 are very, very low, right? This is pretty close to being able to pass that no problem. And then seniors, the master's students, your guys' biggest worry more is actually making something that looks interesting to future employers. So if you're sitting here working on this cool architecture that you can't show someone on a resume or show someone in a playable demo, it's not going to help you a whole ton. Right? Having the knowledge is certainly valuable, and that's what's going to help separate you from other people in the industry. But if you're trying to get a job, getting something up and playable like this is way more valuable than thinking about the best way to thread an engine or something like that. So now again, I like architecture, and I know a lot of you guys like architecture. This is why you're coming to Game Engine Architecture Club. We like solving problems, we like learning new things, we like doing really awesome kind of stuff, and this learning is important. But we can start adding these base games after we get them up and running. Right? We've got the whole rest of the semester to experiment. If it turns out that all that advanced stuff you were doing, painting yourself into a corner, doesn't work, and you can't get it finished by the end of the semester because all these bugs, you've got something you can already turn in, just sitting there from the beginning of the semester if you start like this. You can also just kind of relax. They go at such a rapid pace. Again, give yourself some free time, some breathing room, concentrate on other classes, and actually pass them. So all kinds of nice things you can do if you have a playable game, near the beginning of the semester or even before the semester even starts. Now certainly some games, this keep things simple and don't use advanced features doesn't make much sense for. Kind of, right? So take Nitronic Rush. Everyone here familiar with Nitronic Rush, I'm assuming? Everyone's seen it, at least vaguely familiar with it. Looks really, really amazing, right? It plays amazing. It's got these really cool physics. The car can fly around, and it's got, the actual wheel physics going around, sticking to different walls and all that. If you guys saw their first tech demo, it really wasn't that impressive at all. It was this car. I don't even remember if it was the car. Sean, do you remember if it was the car or was it the tank from CS250? The Jeep. Okay, yeah. So they had the GAT 300 Jeep driving around in a flat plane. It did not look pretty, and the physics actually didn't work in the general case, if I recall. Like, it didn't deal with the tons of situations properly. It was just a car driving around a flat plane. All right. It was a tech demo, right? But they could play it. You could sit down, you could have the controller, you could see the car move around and, kind of do a little bit of the sway and stuff. So it was fun, it was motivating for them. Instead of working in all this architecture and stuff that they didn't really care about, they had the core mechanic of their game up and running, and they were so happy because, here they were just totally ready to actually now make this car do cool stuff, rather than just sitting here wondering, oh, when are we finally going to be able to play this game? They could do it right then. And it was also, again, a prototype. It proved that they could do the hardest part of the game, which is getting the car mechanics to work, so that they didn't then spend an entire semester building all this other stuff for a game that they could never manage to get working. So this saved them in the event that they couldn't get it up and running, but thankfully, of course, they managed to pull it off quite amazingly well. Same thing with AAA titles. All these big, $20 to $100 million games. A lot of them are prototype first. Most of them are prototype first. And a lot of the times, these bigger engines that you see being used are used more for prototyping are used because of the ability to quickly prototype. To go, we've got this idea for what we want to do, we're not sure how it's going to work, we're just going to build something as quick and dirty and ugly as possible just to make sure that it's up and running and we can put it in front of somebody and say, hey, does this seem like a cool idea? You know, should we spend 2 to 4 years of our lives and $100 million working on this? That's really important. They don't sit there and do 4 years of development just to then find out if the game is fun. So these engines have a lot of complex features, but these complex features are there to help save time because they don't have to implement them. Right? That's the whole reason that these complex engines are valuable. When you're a DigiPen student or you're a hobbyist or an indie developer who's doing things from scratch, those complex features now are costing you time. You have to implement those features. So the complex features themselves aren't actually valuable. The time saving is valuable. So implementing complex features that's not saving you time is not valuable at all. Only think about the features you actually need. Another thing about AAA engines, so something I think most people know after they've worked with some of them is that there is no perfect engine and they all pretty much suck. Some of them are really pretty, some of them are really fast, some of them have some really great qualities to them, but if you sit down and work with them, you will almost certainly have many moments where you're just banging your head against a desk because they're doing something just horribly wrong. And when I say all game engines suck, I mean all of them. Whatever perfect engine that you have sitting there rattling around in your head, and you're thinking, oh, I've got to have this cool idea to make it perfect. No, it's going to suck. I hate to break it to you, but you're going to get it up and running, and afterwards you're going to regret large parts of your engine. And that's just the way it's going to go. Right? So instead of sitting here worrying about how to build a perfect engine, worry more about making the perfect game, because that's actually attainable. That's something that we've all played. We've all got games that we love to death, that the reasons we came here to DigiPen, right? Those things can happen. The perfect engine can't. Worry about the perfect game, not the perfect engine. So in summary, make a game, not an engine. Right? That's the important part. Only write what you need and nothing more. If you don't need scripting or metadata or threading, don't worry about them. Right? Get what you need, and if you want to play around those technologies, do it later when you're on your own time and you don't have your whole team riding on you trying to get something that'll pass class. Be quick and dirty. Don't worry necessarily about how clean the code is or if it's well architected or well abstracted. Get it up and running, and you can refactor after. Right? That's a complete option. Prototypes can still be fun, so don't think that prototypes are boring or have to be uninteresting. This was essentially a prototype, and it seemed pretty fun to me. And primarily, engines come from games. All the big AAA engines, all these really popular engines you see, they didn't start out in this vacuum, some guy making an engine and then sold it for $100 million or $100,000 to these people licensing it. What happens is some company makes a game, they got all this code, most of it's, again, pretty crappy. The game's successful, so they make a sequel, so they take the first game, they clean up bits of it, add some features, that game's successful, maybe they make a third one, and at that point, because they've built 3 games, they can now take the common parts of these games and the reusable part of this game and separate it out, and that's where their engine that came from, right? That's where the id engine and the source engine and the Unreal engine, all these big, fancy engines, that's where they came from. They came from games, not from someone sitting down thinking about how to write the perfect engine. And that's all there is. So, questions, anything? No? Oh.
If you don't have a game concept, should we just still work on an engine?
Okay, so the question is, if you don't have a game concept, should you work on the engine? I'm leaning towards saying no. You should probably just start brainstorming game concepts. And the nice thing is, again, 8 hours I built that prototype. If you're not sure if a game concept is fun, don't think about an engine, just build an idea. And if you're not sure, now you can sit it down and say, nope, that wasn't fun. Or you can say, yeah, I was on the fence about that idea, but yeah, this was a blast, right? And then that can help you now decide where you're gonna go. Especially because if you don't know what game you're building, you don't know what engine to build. The features that will work for certain games are completely useless for other games or will actually hinder you. So you really want to aim towards having an idea. There are certainly games in DigiPen that have succeeded fairly well by changing their concept several times. So they had a nice engine to be able to rapidly iterate. There obviously is still value in having some engine components. And there are certainly things that you're going to need. You're going to need some kind of math library, things like that. But again, you can only go so far before your team is stuck not having anything to build on except for just little bits and pieces that don't actually do anything. And even if you're talking about you want to rapidly iterate on something, again, having a simpler code base might make that a lot easier than having a complex code base. Any other questions? All right, thank you.